right, hello math students. Today we're doing our cosine functions. So remember when we talked about our circles, right? If I have a unit circle here, unit circle means my coordinates are all 1, right? Radius is 1. Draw a circle, that's my unit circle, right? Whenever we have a initial ray, terminal ray, we have this xy coordinate. We said that x is the cosine of the angle and y is the sine of the angle, right? You remember that because we did our right triangle trigonometry, where here's the angle theta, here's x, here's y, here's 1. So if I do my sine ratio, it's going to be y over 1. If I do my cosine ratio, it's going to be x over 1. And that's how I got simplifying it to x equals cosine theta, y equals sine theta. So we've been doing sine, but now we're switching to our cosine function. All right. So basically, we're going back to our Ferris wheel. Remember the Ferris wheel had a radius of 25 feet. The center, or the midline, was 30 feet above the ground. And it takes one rotation, so one rotation equals 20 seconds. So if I do 360 divided by 20, we get, I'll show you the math, but I know that, 360, divided by 20, we get 18 degrees per second. Okay. Okay, so now we're going to use this to describe the shadow. So the shadow, all we're going to look at is the x coordinate. Sine was looking at the y coordinate, we're going to be cosine is going to be looking at the x coordinate. So what we have is horizontal distance, right? Horizontal is x, right to left directly beneath the Ferris wheel. When we're looking to our far right center, we have positive, far left negative. So on the far right, we have 25. Far left, we have negative 25. So if the far right equals 25 feet, and the far left equals negative 25 feet, what would Carlos' position be on the Ferris wheel when the shuttle is located at 0? 0 will be halfway, so this will be either top or bottom of Ferris wheel. Okay? And that's it, top or bottom of Ferris wheel, because that's at 0. So we're going to sketch a graph of the horizontal location of Carlos's at time t. So we know at time 0, we're going to have time and horizontal distance. I like to make a table because that helps me with my coordinates. So I'm going to use times 0. It takes 20 seconds, it takes 20 seconds to go all the way around, so we'll go increments of 5, 5, 10, 15, 20, they go to 45, 25, 30, 35, 40, and then I'll do a 45 over here. So we know at time 0, they're at the far, sorry, I was a little, taking my eyes a little bit, the far left, right. So we start at far right, start far right. So that means we're at 25. Well, halfway around the circle is 10. Halfway around means we're at negative 25. 20, one full circle, 25. 30, negative 25. 40, 25. 45, negative 25. Now, the top or bottom are the top is at 5, right? Because we go around the Ferris wheel. So let's draw my Ferris wheel. Boom. Right, we have an XY coordinate grid. Here's my Ferris wheel. This is 0 seconds, and this is 20 seconds. That means this is 10 seconds. This would be 5. This would be 15. Repeat, multiply that by 2, it repeats every time. So after 5 seconds, we're at top. We're back at distance at 0. This is negative 25. This is 0. This is 0. This is negative. This is positive 25. Right? So 15 is at 0, 25 0, 35 0, so forth. So let's plot those points. 0, 25. 5 0, 10 negative 25, 15 0, 20 25, 25 0, 30 negative 25, 35 0, 40 positive 25, 45 0. And then it's just like a sine graph, so we just connect the dots with a curve. And there's the cosine graph. Okay. There you go. The amplitude is 25, because that's the radius. Okay. Right now, our midline is 0, 18 degrees per second. So that is how we're able to graph this function. Remember, cosine and sine graphs are very, very similar. We should note that cosine starts on the y-axis, where sine usually starts at 0, 0 at the origin. All right? And so there's my sketch. Now, just like we did with the sine, we're going to find a couple distances that they want us as well. So we're going to calculate the location of Carlos's shadow at t times given the following table. Well, t represents the number of seconds since Carlos passed the farthest right on the Ferris wheel, and so forth. So 1 second. So again, it's 18 degrees. So we have 360 divided by 20 gave us 18 degrees per second. So that means this will be 2 seconds at point B. That'll be 1 second. There's 3 seconds. There's 4 seconds. 5, 6. There will be 8 seconds. 8, 9, 10, 11, 12, 13, 14 seconds. 18 seconds. We repeat. So this is also 23. This is also 28. And back here is back at 40 seconds. So again, we start at 25 feet. So the horizontal position should be 25 feet at 40 because that is 2 complete rotations. So back at the start. Okay. So that's why we're at 25 feet there. Now, if we look at 2 seconds, for instance, they drew the triangle here for us. So I'm going to blow that triangle up. So here we have the triangle. This is 36 degrees, hence 18 times 2 is 36. That's how we got 36 degrees there. This has a radius of 25, and this is the value we want to find. So this is our cosine ratio. So the cosine of 36 degrees is going to equal the adjacent side over the hypotenuse. So really, that's this equation. X is going to equal 25 cosine of 36. So this is going to be 25 cosine of 36 degrees. And we can use the same logic to do 1 second, but instead of 36, it'll be 18. Instead of 36 for 3, it'll just be 18 times 3. Instead of 4, 18 times 4. Instead of 8, we could do 18 times 8 because we learned that our calculator now, before we didn't know that we could change positive and negative, but we know our calculator will do negative for us. We know 8 should be negative because on the other side, remember last time we had to create this angle to do some subtraction. But since we learned our calculators can do negative with 8 degrees, we don't need to do that anymore. So this will be 25 cosine of 18 times 14. This will be 25 times cosine of 18 times 18. 25 cosine of 18 times 23, which technically should be the exact same thing as 3. And 25 cosine 18 times 18, 28, which should be the exact same as 8. All right. So then I just plug it into my calculator, and I get 25 cosine of 18. I get 23.8 feet. So that makes sense because if this is 25, we'll go slightly to the left. 25 cosine of 18 times 2. Gets me to 20.2. Again, it makes sense because we're going more towards the origin, more towards the middle. 25 times cosine 18 times 3, 14.7. 25 cosine of 18 times 4 is 7.7. Now, when we go to 8, we should be on the negative x value. So I should have a negative x value. And I do. I get negative 20.2. 14, we're still on the negative x. Times 14, I get negative 7.7. Now, with cosine 18, we're back to positive because we went back past the origin. And then back in the positive. 23 should be positive. 23 and 3 should be the exact same answer. And they are. And then same thing back to negative, but 28 and 8 should have the exact same answer, which they do. All right, so that's how we found those calculations. And then it says give our general formula for any location. Well, if you just looked, all I did was 25 cosine of 18 degrees times the time, and the time is t seconds. So I'll say this is an f of t function. There's my equation, there's a table of values, and we graphed it on the other page. And that is our intro to cosine of our angle. Thank you for listening.